Okay, so what are the factors that affect equilibria of potassium and the availability of potassium in soils? There's four major factors that affect this. Number one, the type of clay that's present. I think this was illustrated in those data sets or those tables that I share with you from those publications from 1979. The type of clay that's present. One-to-one type clays simply don't contain potassium in interlayers because there is no interlayer. And thus, those types of clays don't fix potassium. They actually have a lower CEC. You learned about this in the CEC unit, right? 2-to-1 type clays are more important for potassium and feeding potassium to exchange sites than 1-to-1 type clays, simply because of potassium potentially in interlayers or greater CEC overall, and the ability of those soils to hold on to potassium on the CEC sites. Point number two, the amount of clay. The more clay, the more CEC, the more potassium that can be on exchange sites. This is why I like being a soil scientist, because that concept makes a lot of sense. Okay, number three, temperature. Increasing soil temperature increases potassium release because temperature affects diffusion rate and temperature affects root growth. So the greater amount of roots present, the greater the plant sees potassium in the soil, because the plant is actually, quote, seeing more of the soil, even though the plant never really sees more than about 3% of the total soil volume. But as plant growth continues throughout a growing season, the plant sees more of the soil and it sees more potassium. There's actually a connection between this in terms of plant growth and mycorrhizal associations with roots that are symbiotic, where these arbuscular mycorrhizae form a symbiotic relationship with roots. The hyphae grow out into the soil. The fungus actually sees more soil. And just like with phosphorus, it sees potassium and picks up potassium and delivers it to the plant. And this is a function of temperature. Also, highly important for potassium and availability is moisture. Increasing soil moisture increases potassium release. It certainly increases diffusion rates, and it increases potassium uptake. If a soil has plenty of moisture, the pathway from the source of potassium on the edge of clay, the CEC sites, to the root, based on greater moisture, the pathway is less tortuous. And so it's easier for potassium to go from point A to point B when there's moisture present. When there's very little moisture present in the soil, the pathway for potassium to find its way from the source to the sink, i.e. from the CEC sites, to the root is more tortuous. And so moisture is a very important factor for delivering potassium to the roots. Then I think about this concept of moisture, and I think about my poor peace lily. And I can tell you that one of the factors that affects potassium delivery to this plant is that sometimes I simply forget to water it for about 2 weeks. And when I start seeing it wilt, it's already past the point where it's suffering from a potassium deficiency. I should know better as a soil scientist. But like I said earlier in this unit, sometimes I get home and I just want to not think about soils for a little while. And I should be thinking about them all the time with respect to this poor plant.